Hello viewers, welcome to my channel Experience Physics and also the topic motion under gravity. So this class motion under gravity, and in that topic motion under gravity we are going to consider balloon type problems only. Balloon type problems. So you know the gas balloon, either it is helium or hydrogen, they are used to float in the air, right? So they have their own acceleration or constant velocity. This data will be given in the problem, constant velocity or constant acceleration. So to solve these kind of problems, you have to look for the data of constant velocity and constant acceleration, right? So they will be used in the air to float in the air, right? So let us go to the problem straight away and we will see them one by one. The first one is an object is thrown vertically upwards with a non-zero velocity. It has some velocity, right? If gravity is turned off at the instant the object reaches the maximum height, what happens? The object is thrown with some velocity, non-zero velocity. If the gravity is turned off, when it reaches the maximum height, it has reached the maximum height, right? So it is turned off, it reaches the maximum height, this is the maximum height. At this place, G is made as 0. Gravity is turned off, right? We are assuming that the data is like that. They assume to consider G is equal to 0, where at this point, this is important. After reaching the maximum height, so after reaching the maximum height, what the object will do, if G is present, if G is non-zero, that is if G is 9.81, this value is available, they will come down and reach the ground, right? Isn't it? But here at this place the G is turned off, it is made as 0. Let us read the options. The object continues to move in a straight line. The object continues to move in a straight line. First one. The object will be at rest. It will be here only. The object falls back with uniform velocity. It is coming down with constant velocity. The object falls freely. It falls freely, free fall, right? Definitely these two will not be the right answers because G is 0. If the object has to come down, G must be there. Actually, G is the pulling the object, right? So option C and D are wrong. Either A or B. The object continues to move in a straight line will not be the right one because already it has reached the maximum height. That is the point. Already it has reached the maximum point. There is no possibility for the object to go beyond its maximum height. That is the maximum height. It can go up to this level, right? So this will be at rest. Option B is correct answer, right? If you assume, right, I am going to change the statement of the problem. If G is made as 0 at this point, if at the middle point, before reaching the maximum height at anywhere, here or here or here or here, at anywhere, there are so many points available, there are so many heights available. That is, before reaching the maximum height, if any one of the heights, at any one of the height, if G is made as 0, what will happen? Then A will be the answer. The object will continue to move in a straight line. According to Newton's first law of motion, the object will be continuing in its straight line of motion unless otherwise the opposing forces are acting, right? We assume the opposing forces, that is the air resistance, there are no air resistance we assume. So the object will be moving upward if G is equal to 0 at the midpoint, not at the maximum height. So as far as this problem is concerned, A is the right answer. Right. Problem number 2. A stone is dropped from a rising balloon A balloon is going up. Yes, let us say this is the balloon, rising balloon. A stone is dropped from a rising balloon at a height of 76 meter above the ground. This is 76 meter. A stone is dropped. Stone is dropped. And it reaches, the stone reaches the ground. It reaches the ground in 6 seconds. What was the velocity of the balloon when the stone was dropped? At this point, what is the velocity of the balloon? Say V. V is equal to what? Right? Velocity of the balloon at this point. So, stone is dropped down from 76 meter. Let us use this formula. S is equal to ut plus of a t square. Velocity V of the balloon is nothing but initial velocity of the stone, isn't it? The balloon is rising up. It is having some velocity at 76 meter height. Then a stone is dropped, right? The initial velocity of the stone is nothing but this V. That is asked. What was the velocity of the balloon when the stone was dropped? That is initial velocity of the stone. So this formula is written for the stone. For the stone, I am writing the formula for the stone. So initial velocity is to be calculated. What is the height? 76 meter, but we have to write it as minus 76. Displacement, final position minus initial position. So minus 76 is equal to, U is in question, T is given 6 seconds. This is plus A is equal to minus G. Always it is minus G, you know it. It is acting downwards. So this will be minus of into G value is 10 into T is 6 square. So minus and minus, so we have to make it as minus 76. This is U6 minus 5 into 6 square. This is 6U minus 5 into 6, 30, 30 into 6, 5 into 6 into 6 is equal to 180, minus 180, minus 76, minus 180 is taken here. So this is 180 minus 76 is equal to 6U. This is 104 is equal to 6U, and U is equal to 104 divided by 6, that is 52/3 meter per second. The options are 52/3 meter per second, upward 52/3 meter per second, downward. These two are wrong. So either 52/3 meter per second upward or 52/3 meter per second downward. Which one is right? Upward is right, because this is plus U. The balloon is moving up. The stone may come down, but the initial velocity of the stone is nothing but the velocity of the balloon. The velocity of the balloon is in positive direction. So it is upward. The answer is 52/3 upwards. This is problem number 3. A balloon is ascending upwards with a velocity of 12 meter. Velocity is given as 12 meter per second. When it is at a height 81 meter height from the ground. From the ground, the balloon is at 81 meter height. Yes. Its velocity is 12 meter per second. So this 12 meter per second is constant velocity, right? When it is at a height of 81 meter from the ground, a body of 2 kg is dropped from it. A body of 2 kg is dropped. 2 kg is dropped. If G is equal to 10 meter per second square, the body will reach the surface of the earth. This time is asked. What is the time required for the 2 kg drop? 2 kg object, right? Here we need not consider the mass value, you know. Kinematic equation, they won't consider the mass value, they are mass independent, right? So this is 81 meter, this is time to reach the ground. So 12 meter per second is velocity. Once again we will use this formula, S is equal to ut plus half at square for the body, 2 kg body, right? What is the distance? 81 meter. Please remember this is minus 81 is equal to u value is 12 meter per second, but balloon is moving up, so this will be plus 12. Plus 12. T value, this is in question, minus of A value is, it is G is equal to 10 meters per square, second square into T square. So this is 5, okay, minus 81 is equal to 12T minus 5T square. 5T square minus 12T minus 81 is equal to 0. This is one quadratic equation. It looks like a square minus bt plus c is equal to 0. So here a is equal to 5, b is equal to minus 12 and c is equal to minus 81. So t is equal to minus b plus or minus b square minus 4ac divided by 2a formula will be used to find the values of t. Minus b is minus 12, minus b is plus 12, plus or minus b square is 12 square, this is 144, minus 4 into a value is 5, c value is minus 81 divided by 2a, 2 into 5, yes. So this is 12 plus or minus 144 minus 4 into 5, 20, minus into minus, this will be plus, 4 into 5, 20, 20 into 81, 16, 20, yes, 16, 20 divided by 10. This is equal to 12 plus or minus square root of 1764. 1764 divided by 10. So square root of 1764 we have to find. Square root of 1764, right? So if it is square root of 1600, this is 40. If it is 1600, square root of 1600. So the answer will be the nearest to 1600. 1764. 1764. So it will be nearer to 40, 41, greater than 1600. So 40, 41, 42 or 43. Let us try 41. 41 square. 41, 4, 6, 1681. So 41 is wrong. 42, by trial and error I am trying. 42 square I am trying. 2 into 42 is 84. And this is 8 and this is 1, 6, 4, 8 plus 8, 6, 7, yes. So 42 is right, 1764. 12 plus or minus 42 by 10. So this will be 42 plus 12 divided by 10 or 12 minus 42 divided by 10. This will give negative value. So this is wrong because time won't consider negative value. We won't consider negative value for time. So this is 54 by 10 is equal to 5.4. The answer is 5.4, second option C. Similar to the previous problem. In the previous problem, acceleration was given. Here velocity is given. So this is upward velocity. So displacement is downwards for the stone. We are writing this equation for the stone, right? So this way we are using the formula for the calculation. Next problem, a balloon starts rising from ground from rest with an acceleration 2 meters per second square. So the balloon has some acceleration 2 meter per second square from the ground, from rest. A balloon starts rising from ground, from rest with an acceleration 2 meter per second square. Just after 1 second, a stone is dropped from it. The time taken by the stones to strike the ground is nearly what? A stone is dropped. A stone is dropped. When? After 1 second. From rest, it is rising up. The balloon, it is going up. 1 second of the time, a stone is dropped from the balloon. How long time it will take for the stone to reach the ground? This time is asked. Not 1 second, we have to calculate. What is the time taken by the stone to reach the ground, right? So 1 second of time, it will have some height. The balloon will have some height from the ground level. First, let us find the height. What is that height, right? So S is equal to ut plus of at square. Yes, we are going to find, instead of S, I am writing h. Look at it, plus h I am using because this is upward motion is equal to, this is 0 from rest, the balloon is rising up. This is minus of into 10. A is minus G, G will have 10, it is not given. If it is not given, you can assume G is equal to 10. So minus of into 10 into T value is 1 second. So this is 1 square. No, I am sorry. Here you shouldn't put 10 here because the balloon has its own acceleration. The balloon has its own acceleration, right? After nullifying the gravity, acceleration due to gravity, the acceleration due to gravity is 10. After nullifying this value, it is having its own value, right? So we should not have this value. Be careful. H is equal to 0 plus 2 meter per second square is plus of into 2 into 1 square. Yes. So height is equal to 1 meter. 1 square is 1 meter. So this height is equal to 1 meter. In 1 second of time, with an acceleration of 2 meter per second square, the balloon would have reached a height of 1 meter. From that 1 meter, a stone is dropped. Yes, a stone is dropped. How long time it will take for the stone to reach the ground? This time is asked, right? So once again, for the stone, I am going to write the same equation. S is equal to ut plus of a t square. Now you can use the G value, 10. 10 you can substitute here. In fact, it is minus 10. Why? The stone is falling down due to gravity only, right? But U is missing. The stone will have some initial velocity because the stone is moving up along with the balloon. The balloon's velocity will be the stone's velocity. The balloon's velocity at this point will be the initial velocity of the stone. So we have to calculate that value. I can use this formula. V is equal to U plus AT for the balloon. This is for the balloon. V is equal to U is equal to 0 because it is from rest, plus A is equal to 2 and the time is equal to 1. So V is equal to 2 meter per second. At this point, velocity of the balloon is 2 meter per second. So at this point, the stone will also have 2 meter per second velocity. That will be the initial velocity. Yes, 2 plus symbol because initially it is having upward motion. Time we do not know. In fact, that is to be found minus of into 10 into t square is equal to minus h. Please remember, this is minus h. That value is 1 already we have calculated. minus 1. So minus 1 is equal to 2t minus 5t square. This can be rewritten as 5t square minus 2t minus 1 is equal to 0. Once again it is quadratic equation, we can easily solve it to find the value of time. Minus b 2 plus or minus b square 4 minus 4, a value is 5 and c value is minus 1 divided by 2 into a is 5. 2 plus or minus, this is 4 minus into minus plus 4 into 5, 20 divided by 10. So this is 2 plus or minus root 24 divided by 10. Square root of 24 we have to find. If it is square root of 25, easily we can write 5. So the approximate value is 2 plus or minus 5 divided by 10. So this is 2 plus 5 is 7. 7 by 10 is equal to 0.7. The other value 2 minus 5 is minus 3. Minus 3 we need not consider because time value won't have negative value. So this is 0.7 second. In the question itself, they have mentioned the nearest value can be substituted. So it is nothing wrong for you to consider root 25 instead of root 24. 0.7 is the right answer, 10.1, 0.7. Yes. Next one. A body is allowed to fall from a height of 100 meter. From a height of 100 meter, this is, assume a building, a body is allowed to fall. After 2 seconds, if acceleration due to gravity vanishes, after 2 seconds it is falling. Assume this is happening for 2 seconds only. Then at this place, G is made as 0. Gravity vanishes, that is G is 0 at this point. The total time of its fall is, what is the total time? Total time of fall. Yes. This time is asked. So, for 2 seconds, G is equal to 10, isn't it? It is given G is equal to 10 here. G is equal to 10 here for this part. For the remaining part, this is ground. For the remaining part, G is equal to 0. At this place, G is made as 0. That is, it is vanished. It is becoming 0. Right. So this is a two-part problem. Part 1, G is equal to 10. Then part 2, G is equal to 0. Part 1 is this distance. Part 2 is this distance. The entire distance is 100 meters. How long time the stone will take to reach the ground if this condition exists, right? Using the 2s value, first let us find this height. From the time value, we are going to find the height. G value is available. So use this formula. S is equal to ut plus of a t square. S is equal to minus h. It is falling down. U is equal to 0. So from the top of the tower, it is falling. So initial velocity is 0. This is minus of into G value is 10. So 10 into time value is 2. So this is 2 square. This will be 2, this is 5. So h minus into minus cancelled, 5 into 4, this is 20 meter. So this height is 20 meter. So this height will be 80 meter. Yes, 100 minus 20, 80 meter. So for the part 1, with G is equal to 10, it is traveling for 20 meter. Then the rest of the distance, 80 meter, it is traveling without G value. No G value here. So here G is equal to 0. Now we are going to find the time, right? S is equal to ut plus of a t square. This time we have to find. So G is equal to 0. So this part will be 0. G is equal to 0, right? So instead of A, if you write G, G is equal to 0. S is equal to UT only. S 80 meter minus 80 is equal to U into T. This time is in fact asked, but we do not have the U value. For the stone, at this point, it will have some velocity. That velocity is U, not this velocity. This velocity is from the top of the tower. But at the 20th meter, it will have some velocity. That velocity is the initial velocity. We have to find the U value here. Right. So that U value will be nothing but the final value of the part 1. Part 1, final value V square is equal to U square plus 2AS. V square is equal to, for the part 1, this U is equal to 0 here. U is equal to 0. This is minus 2 into 10 into 20. This is also minus. So V square is equal to 20 into 20. V is equal to 20. V is equal to 20. So in fact, this is minus V the whole square. This is also minus 20. Yes, dropping down, right? So minus V square will become plus V square, and this minus will become plus. V square is 20 cross 20. V is equal to 20. At this point, V is equal to 20 is nothing but the final velocity for the part 1. When it is crossing 20 meter, its velocity is 20. That will be the initial velocity, minus 80 minus 20. Since it is coming down, I am using minus symbol T. So T is equal to 4 seconds, right? This velocity will be the initial velocity. This final velocity of this point in part 1 will be the initial starting velocity for the part 2, right? So T is equal to 4 seconds. So this time is 2 seconds. This time is 4 seconds. So total time is 4 plus 2, 6 seconds. Option C. Yes, next problem. A balloon was moving upwards with a uniform velocity of 10 meter per second. Velocity 10 meter per second. This is uniform. An object of finite mass we don't consider, right? Finite mass is dropped from the balloon when it was at a height 75 meter from the ground level. The height of the balloon from the ground level when the object strikes the ground was the height of the balloon from the ground when the object strikes the ground, right? Balloon is moving up with an velocity. Yes, the balloon is moving with some velocity 10 meter per second. An object of finite mass is dropped from the balloon when it was at a height 75 meter, right? This height is 75 from the ground. An object is dropped, finite mass, the height of the balloon from the ground, the balloon is going up and up, isn't it? Only the object is coming down, but the balloon continues its travel in the air. It is going upwards. The height of the balloon from the ground when the object strikes the ground was, the object is taking some time. It is taking some time to reach the ground, T. It may be 3 seconds or 5 seconds, some value it is taking. At that time, how much distance the balloon would have reached after 75? This is 75 meter. This is 75 meter. Then it will be some distance, say H1. So 75 plus H1 will be the answer. The balloon is rising up. You read the problem carefully. The balloon is rising up. At 75 meter height, an object is dropped. Then the stone is coming down. Simultaneously, the balloon is going up. The stone is taking some time to reach it. That time, the balloon will be at some height. What is that distance? The distance must be calculated from the ground. From the ground. Right. So first let us take this part. Let us calculate what is the time taken by the object to reach the ground using the value 75 meter and 10 meter per second. This is uniform velocity. Look at the word uniform velocity, right? S is equal to ut plus of a t square. This is 75 meter plus 75. So no, the stone is, I am writing this formula for the object. The time taken by the object to reach the ground I am calculating. So this is minus 75 is equal to uniform velocity 10. Time is to be found. So t, look at it, it is plus 10. So the balloon is going up. When the stone is or the object is dropped, it is having the velocity of the balloon, it is positive value. Minus of into g value, yes, it is 10 t square. So this is 5. So 5t square minus 10t minus 75 is equal to 0. We can divide the entire equation by 5. T square minus 2t minus 15 is equal to 0. Once again, this is a quadratic equation, power 2, power 1 and one constant. So this is a quadratic equation. Minus b is plus 2 plus or minus b square minus 4 into a value is 1 and c value is minus 15 divided by 2 into a is 1. So this is 4 into 15, 60. 60 into 1, 60 minus into minus plus 60 plus 4 is 64. So 2 plus or minus square root 64 by 2. Root 64 is 8. So 2 plus or minus 8 by 2. Negative value we need not consider. 8 plus 2 is 10. 10 by 2 is 5. The time is 5 seconds. This time is 5 seconds. The balloon is at 75 meter height. An object is dropped. The object is reaching the ground in 5 seconds. In that 5 seconds, the balloon will be up in the air for some distance, that is h1. Next, we are going to find what is that h1. S is equal to, once again, this formula, ut plus of at square. Yes, I am writing h1 plus h1, look at it, plus h1 u value. What is this velocity? It is 10 meter per second. Yes, this is constant. 10 meter per second. And the time is 5 seconds. In 5 seconds of time, how much distance it should have traveled? Plus 0. Yes. For uniform velocity, when the velocity is uniform, acceleration is 0. Yes. This is the trick here. h1 is 50 meter. Yes. This height is 50 meter. So the total height is 50 plus 75, 125 meter, option C. Yes. This is the last problem. A particle is thrown upwards from ground. It is thrown upwards. It experiences a constant air resistance. Yes. This is a new data. Constant air resistance. What we assume in all the problems under the topic motion under gravity, we assume there is no air resistance. In fact, in class 11 physics, we assume the air friction or air resistance is neglected to apply Newton's law. Unless otherwise, this kind of values are given in the data. If it is given in the data, you shouldn't ignore, you must consider that value. Constant air resistance which can produce a retardation. Retardation is negative acceleration. Opposite to the direction of velocity. It is acting opposite to the direction of velocity. That information also it is given. The ratio of time of ascent to the time of descent. Time of ascent, let me write T1, upwards. Time of ascent. T2 time of descent. A ball is throwing up, it reaches the maximum height. This is ascent going up, and this is descent coming down, descent. Yes. T1 this time and T2. This ratio T1 by T2 is what? Air resistance must be taken into account in this kind of problem. Air resistance must be taken into account. Now the balloon is going up. This is the direction of the balloon. It is going up. So velocity will be upwards. Here it is descent. The balloon is coming down. The velocity of direction is downwards, right? So ascent, this is our balloon. It is going up, direction of V. Then this is G. It always acts downwards. Opposite, look at the word here, opposite to the direction of velocity, because this is retardation, negative acceleration. Retardation, it is opposing the direction of velocity. So this is velocity upwards. Air resistance is acting downwards. This value we know 10. This value is given as 2. Both G and air resistance are acting in same direction. So G net value is 12 meter per second square. This is 2 meter per second square. Opposite direction of the velocity, air resistance is acting. Then for the descent, balloon is going, particle, not the balloon. This is the particle. This is a particle, not the balloon. Yes. It is going down. So the air resistance will act upwards, opposite direction of the velocity. G is acting downwards. So G acts this way, 10, the value is, air acts upwards 2. So 10 minus 2, 8 meter per second square. This is G net. G net is 8 meter per second square. So this is the point we must use in this problem very carefully. The ratio T1 by T2 is asked. So let us relate T1 with which value? So T1 has to be related with some value. That some value is related with T2 also. The common term is h. The common term is h. Height is common. The particle is thrown up. It reaches some height. Then it is coming down. The particle is thrown up. Then it is coming down. So the h is common for both ascent and descent. So we have to relate the h value. So what I am going to do is, h and T1 are related. Similarly, h and T2 are related. Then h is equal to some T1. Similarly, h is equal to some T2, and T1 and T2. The ratio can be easily calculated, right? So V is equal to U plus AT. This velocity V is equal to, during ascent, V is equal to 0. U we do not know during ascent. This value is G net. This value is T1. So U is equal to G net into T1. U is equal to, G net is 12, I think, yes, 12. For ascent, G net is 12 T1. This is one relation, because during ascent, we can't use this formula. S is equal to ut plus of at square. S is the height. Height and time. So we want to relate height and time. Height instead of S, we can write h. H and time we can relate, unless otherwise we know the value of u. But we do not know the value of u, so we can't use the formula straight away here. That is why I am using this formula. Now u and time are related. Using this relationship, we have to relate h and time. So second step, v square is equal to u square plus 2as. V is equal to 0. Final velocity at the maximum height during ascent, that is 0. U square is 12 T1 square is equal to minus 2 into G net is 12 minus value. Why? Both are acting downwards. Yes, G downwards, air downwards, 12 will be minus 12. Minus 12 into H. So this is 2 into 12 into H is equal to 12 square. 12 into 12 into T1 square. This is 112, 112, 2 and 6. So 6 T1 square is equal to H. So H is equal to 6 T1 square. Similarly, for the descent part, this is for descent. Yes, here we can use S is equal to ut plus half at square. Why? During descent, this u value will be 0. We need not have the u value here. So this is 0 minus half into G net and T2 square. This is H minus H, descent coming down. This minus and minus will get cancelled. This is H. Half into G net is 8. Once again, this 8 is having minus value, right? G10 is acting downwards. 10 minus 2 is 8. So this is correct. Minus half into 8 into T2 square. So H is equal to 4 T2 square. Here H is equal to 6 T1 square. Here H is equal to 4 T2 square. So we can write 6 T1 equating both H value 4 T2 square. T1 square divided by T2 square is equal to 4 by 6, that is 2 by 3. So T1 by T2, this ratio is asked square root of 2 by 3. Square root of 2 by 3, option B. So this is the end of the video lecture, guys, right? So if you read the problem twice or thrice, you can easily find the appropriate formula that has to be used to find the result, right? So you read the data carefully before trying to solve the problems, right? This is the end of the video lecture. Thank you for watching. Good luck.